Section 5.6, half-angle identities. We can use the cosine sum identities to divide half-angle identities. So look at the cosine sum here. One of the formula is a cosine 2x is equal to 1 minus 2 sine square x. Since we want to divide half-angle identities for the side, so we try to isolate the sine square x here. So what we're gonna do, we're gonna add 2 sine square x for both sides and then subtract cosine 2x for both sides. Okay, right? Now I'm gonna divide it by 2 for the whole equation. Okay, I do have the square here, so I'm gonna take the square root for both sides. When you take the square root, make sure you add the plus minus. Okay, we want to find the half-angle identities. So half-angle means the x has to be divided by 2. So what we're gonna do, we're gonna let x equal to a over 2. And then we're gonna multiply by 2 for both sides. So you're gonna get 2x equal to a. So I'm gonna replace the x with the a over 2 here, and the 2x that will be equal to a. Okay, so this is my half-angle identities for the side here. You will choose the appropriate side depending on the quadrant of a over 2. So you're going to figure out what quadrant of the a over 2 is and determine it's going to be positive or negative. Now, we want to find the half-angle identities for the cosine x. So what we're gonna do, we try to isolate the cosine square x here. So we can add 1 for both sides. And then we're gonna divide it by 2 for the whole equation. Same idea, we're gonna take the square root for both sides and make sure you do have a plus minus here. And then we're gonna let x equal to a over 2. So 2x is going to be equal to a. And then we're going to plug it back to this equation. So we do have a half-angle identities for the cosine. And again, the side, that will be depending on your quadrant of a over 2. We are done for the sine and the cosine. Now we're gonna take care of the tangent. There are 3 alternative forms for the tangent a over 2. Let's try to work on the first one. The fundamental formula for the tangent will be equal to sine over cosine. And then from the previous 2 slides, we find it out what is the half-angle formula for sine and cosine, right? We just plug it in. And then we're gonna keep the plus minus here, and then we're gonna simplify this guy. So this is gonna be my first forms of the tangent a over 2. Second one, we're gonna do the same thing. We have a tangent a over 2 over cosine a over 2. Instead of plugging the half-angle identities here, I will multiply 2 cosine a over 2 over 2 cosine a over 2. Why we need to multiply the 2 cosine a over 2 here? When I multiply it, do you guys see something similar here? There's a 2 sine a over 2 cosine a over 2. This is a double angle formula for the sine, right? It's supposed to be equal to sine 2 a over 2 here. Remember that sine 2x equal to 2 sine x cosine x. And then on the denominator, I do have a 2 cosine square a over 2 equal to 1 plus cosine 2a over 2. This is from the previous one like here, right? 2 cosine square x equal to cosine 2x plus 1. And then we're gonna simplify it. We cancel out the 2 here. You're gonna get the second formula, sine A over 1 plus cosine A. Okay, how about the third one? We're gonna start working from this guy. Okay, we just get it from the previous line. So I'm gonna multiply the conjugate of 1 plus cosine A. Remember what's the conjugate of 1 plus cosine A? You're gonna times 1 minus cosine A over 1 minus cosine A. And then you're gonna apply the formula here. A plus B times A minus B. That will be equal to A squared minus B squared. Okay, remember the identities? Cosine squared x plus sine squared x equal to 1. So 1 minus cosine squared x will be equal to sine squared x here. And then we're gonna simplify 1 of the side A. So this is gonna be the third formula for the half angle identities for tangent. Okay, here's is how we just divide the formula, sine, cosine, and tangent. Tangent, we do have a 3 alternative form. I need you guys memorize all those formula, okay? Half angle identities. Okay, example 1. Find the exact value of cosine 15 degree using the half angle identity for cosine. So cosine 15 degree, we don't want to use the calculator. So you may want to think about the special triangle, 30, 45, and 60, right? So 15 degree, when I multiply by 2, you're gonna get 30 degree. So we know how to find the cosine 30 degree, right? So now we're gonna apply the half angle identity. We could revise it to cosine 1/2 times 30 degree. Right, 30 degree divided by 2, you're gonna get 15. So this is good. Now we're gonna plug into the formula. And then 15 degree, this is in the quadrant 1. So quadrant 1, cosine will be positive. Okay, remember that this formula is supposed to be plus minus. But since we know the 15 degree is in quadrant 1, cosine in quadrant 1 is a positive. So we just choose the positive here. And then what is the cosine 30 degree equal to? It will be roughly over 2, right? Okay, now get the same denominator. And then we're gonna multiply by 2 here, multiply by 2 here. So we got 2 plus square root 3 over 4. And then square root of 4, which is gonna be equal to 2. You could use your calculator to double check your work, okay? Use your calculator, find it out what's a cosine 15 degree equal to, and then try to use the calculator, calculate this guy, is it equal to cosine 15 degree? Second one, find the exact value of the tangent 22.5 degree using the identity. Again, think about the special triangle, 30, 45, and 60. So 22.5, when you multiply by 2, that will be equal to 45 degree. Right? So we do have a 3 alternative form for the tangent A over 2. You could pick whatever you want, but I will choose this one. I don't want to deal with the square root things here, okay? And my A, that will become 45 here, right? 45 degree divided by 2, you're gonna get 22.5. Now, plug into the formula. Sine 45 will be wet 2 over 2. Cosine 45, same idea, wet 2 over 2. Okay, you could see the LCD should be 2, right? So I could multiply by 2 on the top, multiply by 2 on the bottom. Distribute it, you're gonna get wet 2 over 2 plus wet 2. Then we need to rationalize. So we're gonna multiply by 2 minus wet 2 here. Use the formula a plus b times a minus b. That will be equal to a squared minus b squared, which is gonna be 4 minus 2. And then on the top, you could just distribute the square root 2. Okay, on the top, I could factor out the 2, right? And then 4 minus 2 equal to 2. Now, I could simplify it, cancel out the 2 here. So I left with wet 2 minus 1. Okay, example 3. Given cosine s equal to 2 over 3 and s is in between 3 pi over 2 to 2 pi. Find cosine s over 2, sine s over 2, and tangent s over 2. Since the angle s will be in between 3 pi over 2 to 2 pi, if we want to find out s over 2, we're gonna divide it by 2 here. So you're gonna know the angle for the cosine, sine, and tangent. That will be in between 3 pi over 4 to pi. 3 pi over 4 to pi, which is gonna be your quadrant 2. Okay, quadrant 2. So think about it. For quadrant 2, cosine would be positive or negative? That would be negative, right? How about sine? Sine in quadrant 2, that will be positive. And then tangent on the quadrant 2 will be negative also. Okay, now apply the half angle identities. For the sine is a positive, so I'm gonna choose the positive here. And then you know cosine s equal to 2 over 3. So plug it in. Simplify it. You're gonna get square root 1 over 6. Okay, right? Now, you're gonna multiply wet 6 over wet 6 in here. Rationalize the denominator. So, final answer, wet 6 over 6. Okay, cosine s over 2. And cosine s over 2 in quadrant 2 will be negative. I want you guys try, plug in what is the cosine s and then simplify it. Make sure rationalize the denominator. Okay, check your work. You should get this guy, right? LCD will be 3, 3 plus 2, that will be 5, 5 over 3. Divided by 2, which is going to be a negative square root of 5 over 6. Rationalize. Final answer, negative 30 over 6. Okay, tangent. Tangent s over 2, you could use the formula, or you could do sine over cosine. And then we already figured out what's a sine s over 2 and cosine s over 2. So just plug it in. Simplify it, we should cancel out the 6 here. And then keep in mind, tangent in the quadrant 2 should be negative. So we are in the good shape here, right? Negative. Okay, before I rationalize, I could simplify square root of 30 a little bit. Right? Where 6 times where 5, that's equal to where 30. And then I could simplify the where 6 here. Now rationalize. Final answer. Negative where 5 over 5. Okay, example 4. Simplify each expressions. First one, it looks like the half angle identities. Right? Remember this formula. That's a 1 plus, okay? 1 plus in here. So that's a cosine A over 2. If this is 1 minus, then that will be sine A over 2. So your A will be equal to 12x. So this guy, that will be equal to cosine 12x over 2. Simplify it. So that's equal to cosine 6x. Okay, how about B? This one looks like the tangent, right? Tangent A over 2. And then your 5x will be equal to A. So this guy will be equal to tangent 5x over 2. Okay, example 5. Verify this identity. So we always start with the complicated part, right? Let's start with the left-hand side. I want you guys try to use this formula to expand it, okay? That will be A plus B squared equal to A squared plus 2AB plus B squared. Try. Okay, check your work. And then I do have a sine squared x over 2 plus cosine squared x over 2. Let's group it together. And remember this is the identity. Sine squared A plus cosine squared A equal to 1. How about this guy? That will be the double angle formula, right? 2 sine A cosine A equal to sine 2A. But then your A will be x over 2 here. So you're going to plug in x over 2 for this guy. Simplify it. That's going to be equal to the right-hand side. Okay, that's it.